Okay, and we're back for section 2.2. So let me pull up our screen here. Where are we at? So section 2.2 is all about the change in the average rate of change. We've got this lovely example, and it really is a good example in the table 2.3 here. So we can obtain a better sense of patterns in the US population if we look at how the average rate of change varies over time. One way to do this is to pick a fixed interval for time and then calculate the average rate of change for each successive time period. Since we have the US population data in 10-year intervals, we can calculate the average rate of change for each successive decade. The third column in table 2.3 shows the results of these calculations. Each entry represents the average population growth per year, or the average annual rate of change during the previous decade. A few of these calculations are worked out in the last column of the table. So they're just kind of going through and looking at it, and as you can see, we see the average rate of change, or the change in the average rate of change, it's going up. So we are seeing the population changing. So start at the top of the third column and scan down the numbers. Notice that until about 2010, the average rate of change increases every year. So yeah, we see it increasing. And then from 1910 to 1920, we start to see it change. So not only is the population growing every decade until 1910, but it is growing at an increasing rate. It's like a car that is not only moving forward, but also accelerating. A feature that was not so obvious in the original data is now evident. In the intervals 1910 to 1920, 1930 to 1940, and 1960 to 1990, we see an increasing population, but a decreasing rate of growth. It's like a car decelerating. It is still moving forward, but it is slowing down. Great example. By the way, I'm up at my mom's house and her little dog is going insane. I think it is insane. So let's look at number 2 here. Number 2, calculate the average rate of change between adjacent points for the following function. The first one's done for you. So basically what they did is they just went through and, my pen's not going to work, I forgot, it's dead. Okay. So they went through and said, okay, well, if I do 1 minus 0, I'll get 1. And if I divide, so basically what they're doing is they're taking these values, these are our changes in y's, right? They're taking 1 minus 0 and getting 1. And then they're doing the same thing here. That's my change in x. So that's going to be over 1 minus 0, which is 1, which is just 1. That's how they got that 1. Okay, cool. We're all on the same page. So let's figure out the rest of these. So on this one, because I'm going to have to be very careful since I'm having to write with my finger here. See if we can spread it out. Okay, so to do the next one, so from 1,1 to 216 here, my rate of change, or the average rate, the change of my average rate of change is going to be 16 minus 1. So I'm doing my y's, subtracting my y's out, and then I'm going to do 2 minus 1. So I get 15 over 1, which is just 15. So that one's going to be a 15 there. And then we can do it again. I can do 81 minus 16 over 3 minus 2. So 81 minus 16 is going to be 65 over 1. So we get 65. If you do the next one, if you do 250 minus 81 and divide that by 4 minus 3, you're going to get 175 because I'm out of room. And if you do it one more time, 625 minus 256, and then 5 minus 4, you're going to get 369. Okay, so that's the first part, or the first calculations done here. So in part A, is the function increasing, decreasing, or constant throughout? So what happens is this column is the average rate of change here. Do we see it going up? Do we see it going down? What's happening? Well, our numbers are definitely going up, right? Quite a bit. So the function is actually increasing. So in part B, is the average rate of change increasing, decreasing, or constant? So the average rate of change is also increasing, because if you look at your differences between these, you continue to see those differences going up as well. So the average rate of change will be increasing. Okay, cool. So let's look at I'm gonna do number 7. I thought number 7 was cool, and I don't remember why I thought number 7 was cool. Oh, because it's got graphs. Of course it's cool. So in number 7, each of the following functions has a graph that is increasing. If you calculated the average rate of change between sequential equal size intervals, which function can be said to have an average rate of change that is constant, increasing, or decreasing? So in other words, even though all of these are going up, right? When you look at how much they're going, or like their change of the average rate of change, or the change of this going up, even with this going up, it is still increasing, right? Because it's turned upwards. So this one's still increasing. This one's not really doing anything, even though it's going up. It's very consistent with how it goes up. And this one's going up, but it's, you know, not quite as quickly, is it? So here, if I wanted to figure out which one's going to have the constant average rate of change, that's going to be, well, that's going to be the one that gives me the linear graph there. So that's going to be B. And then where it's increasing, that needs to be the one where I actually see it continuing to increase quickly. That would be A. And then, of course, the decreasing, because we really see it slowing down. Guys, we could actually pick points and calculate that it's slowing down there. That would be, all right, cool. That's all I've got for this section. I will decide between now and Wednesday what I want to do, or Tuesday what I want to do. All right. See you on Tuesday.